Cuomo. Oh, there it goes. Excuse me. Um, a NASA Solar System ambassador, a longtime friend of the Seattle Astronomical Society, an occasional member. Tonight he's going to be giving us a presentation on the Mars exploration. Nice little update. News from our robotic explorations. Thank you so much for joining us this evening, Dave. And I will hand it over to you now.
All right. Okay, can you make me? There we go.
Yeah.
All right. Well, hello, everybody. Welcome to our meeting. And I wanted to start out real quickly by telling you a little bit about myself. I am Dave Cuomo, Solar System Ambassador. For those of you who don't know, it's a volunteer program run by the Jet Propulsion Laboratory. It started with the Cassini mission. It started with the Cassini mission to Saturn. The Jet Propulsion Lab wanted people out in the community promoting the science of the Cassini mission at the early stages of the mission. And it became very popular, and they expanded it to the whole solar system. It wasn't just Cassini Saturn ambassadors, it became the whole solar system ambassadors, and really ambassadors to let people know what NASA and the Jet Propulsion Laboratory are doing. I also work at the Pacific Planetarium over in Bremerton, Washington, which is run by Digitalis Education Solutions. We do make planetariums and sell them around the world. We're on every continent, and except for Antarctica, and I know we're working on getting a system at McMurdo. I don't know whether it'll happen. I do want to say that I welcome your questions. I have, over the course of our COVID virtual presentations, I have come somewhat adept at keeping my eye on chat windows so that I can see questions. I'm also somewhat okay with people shouting questions at me. If we were in a real planetarium and I was doing a presentation with you, I might very well sit next to you, hand the controls to you, and let you run the system for a while answering your question. I can't do that here, but if you have questions, please feel free. If I'm going too fast on something, if I'm not clear on something, please let me know. I want you to be able to appreciate what we're talking about. And I want to start by going back to last month, because last month when I did a presentation here on the James Webb Space Telescope, one, the James Webb Space Telescope was still on Earth, and two, there was a question at the end that I didn't answer as quite well as I could have. And I'm going to go ahead and answer that now by sharing this screen with you. And the question was, at the end of the James Webb Space Telescope presentation, was how do we communicate with these spacecraft? The James Webb over 1 million miles away, and the other telescopes and spacecraft throughout the solar system. And I mentioned this website, and I wanted to show it to you because it's actually a quite interesting little website. It is called, and I will go ahead and put the address into the chat window here so that you can get it. It's eyes.nasa.gov, and then a bunch of letters and everything, but it's the Deep Space Network. And to communicate with spacecraft, whether they are in orbit around the Earth, whether they are in orbit around Mars, whether they are in orbit around a Lagrange point, excuse me, or whether they are leaving the solar system entirely, we do that. Through telescopes scattered around the world. There are radio telescopes in Madrid, in Goldstone in the United States, and in Canberra, Australia. So that as the Earth turns, we can always be in contact with things. And as you can see on this right now, Madrid is currently sending and receiving data to the James Webb Space Telescope. And it's from this telescope here, and just receiving data from James Webb. The thickness of the signal that you see there is the strength of the signal. And so you can see down here in Canberra is getting a weak signal from Voyager 2. The MS4 is an orbit around the Earth. It is the, I looked this up just a minute ago and now I can't remember what it is. It is studying the Earth's magnetosphere. It's studying the Earth's magnetosphere. And it looks like Canberra is also locking onto Voyager 1 and Chandra. There are two questions. Does China and Russia use the same system? No. China does not. They work with the European Space Agency and have their own systems. Russia has their own systems, and Russia is a pretty large country. At least covers a big part of the globe. And I'm not certain on some probes that we work with, they would go through the Deep Space Network as well. And then there was a question about when can we come to see a show at the Pacific Planetarium? And that is a great question because the Pacific Planetarium in Bremerton, Washington, we're at 817 Pacific Avenue in Bremerton, Washington. We're a small 25-seat theater, which, as you can imagine, makes social distancing rather difficult. We're also a test bed. It is where we at Digitalis tests the things before we ship them out. It is where we invent our new planetarium systems before we start producing them. And it is often a construction zone. So it's often not quite conducive to being open for the public. We do virtual planetarium shows monthly on the first Friday that are free. And you can find out more about those at the Pacific Planetarium's Facebook page. And we do hope to be able to do programming live and in person. But as you know, this is a very strange time. So with that, I wanted to let you know about the Deep Space Network. Oh, and an update on James Webb. It's fully deployed. Everything worked fine. All of those complicated pieces worked. And it's on its way to its Lagrange point, where it will spend about 2 months cooling down, getting to an operational temperature. Then about 2 months of running through checks. And then they'll start taking some images. But right now, we're going to talk about Mars. And let me introduce you to my planetarium here, okay? I'm going to go through a couple of things that I want to get you oriented to how I'm going to do this program so that it kind of makes sense. This porthole image over here to my right is my planetarium. And we will be taking a look at that in a couple of different ways. Sometimes we might look at it like this. We might see it like this, as though we were outside on a cold night on Mars. There's no air on Mars, or very little, but if we were out on Mars, lying on our back looking up, and this view that I'm looking at here would allow us to see something, say, rising in the east while something else is setting in the west. It's what we would call an all sky view. It's a typical planetarium view. It's what you might see in a planetarium. But for our online presentations, it doesn't make a lot of sense. So we don't use it for online presentations a lot. We're going to go ahead and look at things like this. And I'll also switch between views like this. So we'll go between lying on our back, looking up at the sky in the middle of a meadow or a crater on Mars, as the case may be, or standing up so that we can look around the horizon and see the entire panorama of Mars and what we're looking at here. And there will also be times when I will move around or even go away. Oh, I'll go away so that we can see some of the images that we want to look at. And I'm going to start out here on the ground, and then I'm going to set the stage a little bit for where exactly we are. But this is an image taken from the surface of Mars. It was taken by this spacecraft that we're looking at. This is the Mars 2020 Perseverance rover, and this was a high resolution image taken by its camera that allows us to both see the spacecraft itself, but also we can start taking a look at some of the images that, or some of the rocks, some of the area around which the spacecraft landed. And this is a spacecraft that landed last year, landed in December of 2020, or excuse me, it landed in February of 2021. And because it has a nuclear power system on it, which is right here, it is a decay reactor. It is powered by the, Dave, can I go full screen? Did you spotlight my, am I host, Raina?
You should be. Let me double check here.
Says I've still spotlighted. Ron, if you go up to the top right corner of the of
Aaron,
your screen.
it looks like you're still host. Could you make Dave host?
Yeah, well, Dave, you were saying about the view real quick. Let's see if that solved the problem.
Oh, yeah, click on view and then click on speaker to get full screen. Ron, is anyone else not seeing me full screen?
No, you look good from here, Dave. I want to turn off the lights here and just get really dark and as you take me to space. So
Okay.
Yeah,
Okay.
full screen for me as well.
Thank you, Ron, for asking. I think it was Ron who asked that. Yeah, thank you, Ron, for asking that. I definitely want to make sure that people are able to see the full screen. It's possible when I go back and forth between sharing screens, things might change a little bit. Please let me know. And also let me know if you can't hear me well. Is WB corrected? Is the image that we're looking at color corrected for the colors on Earth? That is a great question. And yes. And a couple of years ago, 2 or 3 years ago, there was a major dust storm on Mars. And during that dust storm, there were released some images that were not color corrected to show the extent of that. And unfortunately, I don't have those readily available. But just to give you an idea, as we look at, say, this regolith here that we're looking at, this is color corrected to make sense to the eyes of geologists who have never left Earth. If it were not color corrected, the red would look more like this, what we have our sky here. So yes, it is color corrected to how it would look on Earth, and that is done because geologists are used to seeing these features on Earth. And without having these features color corrected, it's very hard to understand what you're looking at. And when we're looking at these features on other worlds, the only world we have to compare it to is ours. The only world we have it to compare it to is our world. And yes, I'm going to try to touch on some of the most recent findings from the rover and rovers. We're going to talk about tonight. We're going to talk about Perseverance and Curiosity, and a little bit about InSight and a couple of the orbiters. So yeah, to make it make sense to the human eye. And updates on the sample return mission. You read my mind. Let's go ahead. I'm going to start out and actually let's talk about this mission and why this spacecraft is here. And I'm going to do that by leaving Mars so that we can take a look at where exactly we are. Oh no, we're going to go back to this. Okay, where exactly we are. So we are in this crater here called Jezero crater, Jeezro, which from my understanding means lake in an Eastern European language, a Slavic language. I can't remember which one, so I don't want to say the wrong one right now. And as we look at it, we'll see some features that look pretty familiar to the human eye. I was just mentioning that what we do when we are looking at these worlds is that we compare them to the only world we know, Earth. And we look at the feature and say, well, what would cause that feature here on Earth? So I'm going to fly in a little bit and go ahead and bring up, or I'll bring that down. Bring this up a little bit. I'm bringing in some higher resolution imagery so that we can take a look. And speaking of features that look familiar to us, this certainly looks like an inflow channel. If we move a little to the north, we'll see what looks like another inflow channel. And then just at the edge of a change in image resolution, or between this image and this image, we see what looks like an outflow channel. That was one of the reasons that this crater was chosen as a landing zone for this particular mission, because it has two features that appear as though water was flowing into this crater, and one feature that appears as though water was flowing out, which suggests that it had water in it for a period of time. It wasn't just a flash flood that caused these channels, although these channels could have been caused by flash floods. But there is suggestion that the water stayed for longer than that. And then I'm going to bring in the large gray image, by the way, is taken by the Mars Reconnaissance Orbiter. It is from a camera called the Context camera. And then this next image was taken by an instrument on the same spacecraft called HiRISE that is a more detailed view of smaller areas. The Context camera gives you a view of a large area, and then to give you the context. How do you tell in from out? Oh, on the channels. That's a great question. That is a great question. For a minute, I was wondering what you were talking about. How do you tell in from out? Well, as we zoom in a little bit, we can start to see why this image that I was looking at here certainly looks like an inflow channel, because we've got this delta region forming, and inflow has wider delta. Thank you. Yes, we have this delta region that is forming up here. How high are the crater walls? I do not know. We've got some images that when we get back to the ground, we'll take a look and we can view out to the crater walls and also to this cliff on this inflow channel. So we'll be able to get an idea, but the specific height in meters, I do not know. That is an excellent question. Speaking of which, what are these colors all about? Why are there these colors here? Well, this is telling us the mineralization of this area. So the reddish areas are, as you might expect, iron oxides. They are where iron oxides are located. The bluish areas, or no, the greenish areas are where there are olivines, volcanic olivine rocks. And then the bluish areas are where it's another oxide. I can't remember off the top of my head. I think it is molybdenum oxides that are in this area. So with the predominance of both volcanic activity, the river delta feature, and the iron oxides, you can see how this is a very interesting place to land a spacecraft. I'm going to swing us around so I can orient myself, so I can find the two craters that I was looking for that pinpoint where. So I went the wrong direction. The spacecraft landed. And these two craters are the ones I'm looking for. And the spacecraft landed right about in here. And I'll go ahead and I'm going to share my screen again to show you where the spacecraft is now, and also where the helicopter is. There's a helicopter. We're going to talk about the helicopter as well. So I'm going to share my screen. I'm going to share this screen. Okay, so here is the landing zone. So I was a little off on where I said that it was. Here's those two craters I was talking about. Oh no, I was right. Yeah, there's those two craters I was talking about. There's its landing zone. And this is the path that it has taken. And it's heading over here. as you can see from this image, the cliffs are pretty tall. So the cliffs of that river delta are pretty tall. So the cliffs of the crater itself are going to be considerably larger, although you can see there is some erosion involved. Let's zoom back in here. So the spacecraft itself is right over here. It drove off over into here, and then it came back because there was an interesting rock back here that it wanted to see. So it drove back to there. The helicopter, which is over here, and there was news about the helicopter today. Another first for Mars aviation happened today. I'll talk to you about that here in a second, or maybe I just won't tease it. I will let you know what the first was, because yeah, I'm already committed. Here we go. So I'm going to stop sharing right now. The first was the very first flight on another world that was delayed because of the weather. Happened today. So for all of you who have ever had a flight delayed because of the weather, it happens on Mars too. The image that we're looking at right now here is from the Mars reconnaissance, or no, it's not from the reconnaissance orbiter. Yeah, it is. It is not from the Mars reconnaissance orbiter. It is from another Mars orbiting spacecraft whose name escapes me completely right now, even though I knew it 10 minutes ago. The little circled dot, and I'm going to go ahead and bring it up in here. This little circled dot, this little circle dot right here is the location of the spacecraft. And this image was taken about 7 days ago, and it shows a dust storm forming. And because of that dust storm forming, now it wasn't Mars Express, thank you. It was, maybe it was Mars Express. I'm gonna move on. Because of that dust storm, they canceled today's flight, which would have been the 19th flight. And before this, we didn't know if you could fly a spacecraft or fly an aircraft. What will the findings from the Mars helicopter technology demonstration be used for in terms of future technology development for Mars or other planets in our solar system? That's an excellent question. And they're actually starting to use them a little now. They have actually started the Ingenuity's, the helicopter is called Ingenuity, the rover is called Perseverance, and the flights of Ingenuity have been so successful that they are somewhat using Ingenuity to scout ahead, to scout areas to explore. So it's the flight. It's, I mean, I know many of you in this, I'm not going to, way to go, Ingenuity. Yes. I know many of you in the audience tonight worked making aircraft for our local small Red Barn, Red Shed aircraft company. I don't know if any of you worked in the Red Shed, but Boeing Aviation. So I'm not going to get into the specifics of aerodynamics with you who may know much more than I. But as we know, being able to fly and observe things gives a whole new level of opportunity. So, and with that, let's see what a helicopter flight looks and sounds like on Mars. So if you have, I'm gonna mute my microphone. I would ask everyone to mute your microphones. I don't know how this is going to sound over Zoom, but if you have headphones, you might want to put them on, turn your volume up, because Perseverance has two microphones on it in addition to a helicopter, and we are about to see and hear a flight of a helicopter on Mars. And here we go. And this is courtesy of our friends in Pasadena, California at the Jet Propulsion Laboratory. So I'm going to pause it right there just so that we can get a chance to take a look at it, because that is a helicopter flying above the surface of Mars. And you might have noticed in the captioning, it mentioned that the rotors were rotating at 1200 RPM. And I'm going to go out on a limb here and make a statement that a lot of you aerospace engineers in the audience might disagree with, but from what I looked up, regular helicopter rotors are spinning at about 500 RPM. So Mars's air is thin. And in order, what was unknown was whether or not you could even generate lift on another planet. And well, indeed you can. So this is, yeah, exactly, design validation for what they are doing. And I'll go ahead and start that up again so we can move it. You can see that framing the shot with Perseverance's camera was not a high priority, but they were able to get a good chunk of that. Okay, so with that, I want to move, because I just noticed what time it was, and I want to move along to what's going on with Curiosity, or not Curiosity, We'll go to Curiosity in a minute. But what is going on with Perseverance right now, and why it's been sitting where it is for the last couple weeks, and why it's going to be there for another couple of weeks. And we're going to go take a look at a model of Curiosity, and I'm going to stop us before we fly through Mars. And now I'm going to take us there because I don't want to fly us through Mars. That's always annoying. You get dust on you, and the iron oxide is just kind of abrasive. There we go. So this is a model. As you can see, it is a model that is not on the surface of Mars. I'm going to let time run so I can get some light on it, so we can see some areas of interest to us. This is just a model. It's not to scale. It's not located properly. It never orbited Mars like this. And it'll go on around. There we go. Okay, so here is the spacecraft. I want a little more light. Okay, so here is the rover. In this tool bay, this is an arm that it's the ultimate in Swiss Army knife. It is a multi-purpose tool. It's got scanning spectrometers on it. It has one of the microphones on here. It's got multiple cameras, and it's got a tool that can take a core sample. It can not only drill into a rock, we've been able to do that for a while, but this one will actually take a core sample out of a rock and then move over. And I wanted to show you on this because these two instruments in the image, in the selfie picture that we took, because of the way the selfie picture is taken, could not adequately see these two locations. But right in here is where the robotic arm, after it has sampled a core out of a rock on Mars, it hermetically seals it, puts it into a container in here that hermetically seals it. And then that is then stored inside the spacecraft. And later it will be left, that container will be left on the surface of Mars for a future mission to return it to Earth. Well, the last time they took a core sample, they ran into a problem when they were putting it back into the array. And you can see kind of in the bottom of this picture some pebbles. As they were transferring into the tube, some pebbles ran in there and got in here, and they don't want the pebbles in there because they're going to interfere with future core samples. They're also not sure how much of the core is left in the core sampling device. So they've got a mock-up of the spacecraft in Pasadena, and they spent some time today and the last week coming up with a plan. Supposedly the results of their plan were going to be returned to Earth today. And I was keeping an eye on things to see if that news was available, and it was not, at least not at press time. I did not have any information on it. But what their plan is, they took extensive pictures like this one of the area underneath the spacecraft. And then they are going to rotate the array there to get the pebbles to fall off. And then they'll take pictures to see if they see the pebbles again. And then they'll do the same with the containers to make sure that the container is empty, because this rock, they really want a sample of this rock. So they want to try to sample this rock again. So it's going to take them a while. Today was their test to see if their plan was feasible. And then it's probably going to take them another week to execute the plan. And today excuse me, they executed the test plan yesterday and the day before. Today is when they expected to receive the information on whether it was a successful test, and then they will go through and analyze it and then proceed with their plan over the next week or so. So Perseverance isn't going to be moving much for at least a week or two, and then it'll take another core sample of that rock if everything works the way they hope. So that is our status on Perseverance. It is on its way. Tell you what, let us go ahead and land us back on. No, I'm going to go ahead and move off to Curiosity. I'm going to move away from here because the Mars Science Laboratory Curiosity was also in the news lately with a very interesting finding. And I want to go ahead and fly us over to Gale Crater, where Curiosity is located. And I suppose I could see if I can. I used to be able to find Gale Crater really easy, just eyeballing it. And let me see if there's any questions here. Is the Pebble Jam issue resolved? We're not sure. So cool. They have the sounds of Mars from Ingenuity flights. Very cool. And yes, Titan's atmosphere is 4 times, is much thicker than Earth. So generating lifts will not be as much of an issue on Titan as it is on Mars. And that's Jezero crater. That's not where I want to go. There's where I want to go. Sorry to make everybody dizzy. If we were in a planetarium and you were a classroom full of 7th graders, or 3rd graders is even better, I would ask you if you wanted me to make you dizzy. And you'd start chanting, "Make us dizzy, make us dizzy." And your chaperones would start turning white. And I would laugh. But you're not a classroom of 3rd graders, so I'm going to apologize instead for making you dizzy there. Little out of practice in flying a planetarium. So here we have Gale Crater, which I don't have the resolution. I need to get a little closer. This is where the Mars Science Laboratory Curiosity landed. and where it still is. It is, it landed somewhere up in here. It's currently around over in here. And it took a core sample today. Or not a core sample. It's not taking core samples, but it drilled into a core. It can drill into a rock and take some of, not a core sample, but sample some of the material and analyze it. And what it discovered is very curious, for curiosity. There was carbon dioxide, which is, the atmosphere is mostly carbon dioxide. That's not unusual. But the isotope was isotope 12 of carbon dioxide. And we compare things to things on Earth. And CO2-12 on Earth is produced biologically. Now, that does not mean this is evidence of life on Mars. What it means is that people much smarter than I are right now coming up with all the ways that CO2-12 can be produced non-biologically, to see if any of those methods fit what happens on Mars. And that was the news from Curiosity today. Do you know what the future looks like for missions? Do I know what the future looks like? Sorry. Am I sharing a screen? No, I'm not sharing, correct? No. Do I know what the future looks like for missions to Mars for NASA JPL? Aside from the sample return mission, what are some of the next steps? That's a great question. And actually, that's a good segue to the next spacecraft that I was planning on talking about, because there's another spacecraft orbiting Mars. It is called HOPE, and it is a mission run from the Space Administration of the United Arab Emirates. It is a joint mission with the European Space Agency, and the science is being run out of the Laboratory for Atmospheric and Space Physics at the University of Colorado in Boulder. It's kind of a successor to another spacecraft that UC Boulder ran called MAVEN, and is still running, that is still there. And its mission is kind of a successor. It's kind of a weather satellite. And here are some weather satellite-like images of Mars taken by HOPE. And this brings us to the whole process of how we are exploring Mars and what might be coming next. We first start observing a planet with our eyes. And in Mars' case, we saw very obviously every 26 months, it would change direction in the sky and go backwards and then forwards, the retrograde motion that we are familiar with as the Earth passes Mars in orbit. And we associated it with chaos. Most cultures on Earth did. And then, of course, we look at it through telescopes, and a gentleman named Percival Lowell looked at it through telescopes, and I'm keeping my eye on the time here. A gentleman named Percival Lowell looked at it through telescopes, and he thought he saw canals. And he didn't. He saw dust storms. But then we send spacecrafts to take pictures of it, and we fly them by at 50,000 miles an hour and take pictures. And we go, oh, there can't be any life on Mars. There's no water. It's just a barren world. Then we start getting better pictures, and we go, oh, these features sure look like they were carved by water. Maybe there was water at one time, or maybe it was frozen water, and in flash flooding events, it carved these channels. Then we find evidence that there was water on the surface of Mars by forming rocks that can only be formed in standing water. So we have to go, okay, there was water on Mars, but now there's not enough atmosphere for water to exist as a liquid. So what happened to the water on Mars? Well, maybe when the Mars lost the magnetosphere, the solar wind stripped the water, stripped the atmosphere away, and that's what happened to the atmosphere. So why there's no water on Mars. So we sent a spacecraft there called Maven to discover this. And then Maven has a successor spacecraft in Hope to build on the, just like science, Mars exploration is what I'm trying to say is Mars exploration is a great analogy of the scientific method. You come up, you observe something, you come up with an explanation to explain that something, you test the explanation, you find out that it wasn't exactly what you thought, so you come up with another explanation to explain what you did see, and then you test that. And then you build on your past experiences and build on your past experiences and build on your past experiences. In terms of specific missions, I do not know. There is a Mars sample return mission that will return the samples from Perseverance that is still on the drawing board, that is still being built, that is still the mission, it is still in the early stages of planning that mission. And yes, that will be in the late 2020s or 2030s. And then after that, what other things will we need to test? And of course, eventually, we do want to send a human being there. The technology of that is daunting, to say the least. So with that, I am going to land us back to Jezero crater, where we can take a look at Mars and answer any questions that you might have. So please, thank you all very much. I went a little long, but go ahead and ask some questions.
Yeah, thank you, Dave, once again, for all the latest news. It was really fascinating to see that helicopter. I think sometimes I just have to stop. It's one of those stop and lucky to be alive in these times kind of moments. I have to remind myself that sometimes. Yeah, hope everyone got a chance to hear that audio too. But yeah, we have like 5 minutes here. If anyone have a excited question or anything like that, I know we had Dave answered some questions throughout. Raina, feel free to check out if anything's percolating in the chat. Raina can select some of those, and we can do it that way as well too. So feel free to just type it in or speak up, either way. Yeah. Let's see. Looks like you answered everybody's questions throughout, Dave.
Oh.
Can you cover was it the Europeans and the Russians that recently released data on the trench there and water that had been detected in the soils?
I cannot cover that. Now that you mention it, I am familiar with it, but not in any way able to speak to it. I also was going to talk about the Chinese mission. There's a Chinese orbiter and rover, Tianwen, and I apologize for my pronunciation. Unfortunately, unlike when the Chinese Space Agency landed Chang'e 5 on the far side of the moon, they were very open about publishing things. You were being able to get images back in real time, or not in real time, but they were publishing their images widely. They had a lot of PR going for it. They were very active in getting information out. But unfortunately, for whatever reason, the Tianwen mission that's currently on Mars that is not the case. It's very much harder to find information. Let's see, there's something in here. Mars in the first one is likely covered with surface water like the Earth is presumably Venus, delivered by asteroids and comets. Possibly when Jupiter was plowing toward the inner solar system, Saturn grew large enough to put the brakes on Jupiter from moving further inward. There is some, we know that Mars was a warmer and wetter environment in the past because we know there was water. We know there was water, liquid water on the surface of Mars in the past. So we know that it was warmer and wetter at some point in time in the past. What we don't know is for how long. We don't know whether it was 1,000,000 years or 1,000,000,000 years. And that is what a lot of the missions from InSight, which went and has, by the way, detected Mars quakes, to MAVEN are trying to come up with an answer to how long was Mars warmer and wetter. Let me show you one of the most important pictures taken from the surface of Mars. It was taken by Opportunity, the Opportunity rover. That circle carved, polished there in the middle is about the size between $1.25 and $1.50. Those little nodules there are sphericals of iron oxide that can only form in standing liquid water. So that was the first real evidence that, yeah, Mars had to have been warmer and wetter in the past because there was standing liquid water. The question is for how long? Do we have any idea if we're planning on doing anything there? There is a Venus mission called Da Vinci. It is scheduled to launch in, I think, 2029, possibly 2039, but I think it was 2029. I was just reading about that today. And it will actually fly in the atmosphere of Venus. There are actually 2 missions to Venus. Da Vinci is one of them. And yeah, the end of the 2020s and into the 2030s will be the exploration of Venus. Veritas, thank you.
No, that's thank you so much, Dave. I know we're at time here
Yep.
today, but no, this is great. I know we could talk about Mars. This was kind of an update one, but rest assured, this will not be the last time we see Dave. And we are, for those of you who are joining us a little bit earlier in the meet and greet time, it was kind of serendipitous. We have a few former directors of the planetariums in the area, but SAS is definitely 2022. We're definitely looking at hopefully getting some consistent and multiple different sessions at the local planetarium. So we're looking at ways to do that and when to do it safely. And so be on the lookout. Imagine this looking up in its proper format. So this won't be the last time we're hearing from Dave or experiencing planetariums, hopefully in person. Fingers crossed, everyone. And Mars, of course. Dave's, I want to say it's your second favorite planet, hopefully. Or I don't know.
Yeah, I suppose. Yeah.
I guess default has to be Earth, right?
Yeah,
I think.
although, Enceladus and Europa are definitely creeping up in terms of, and I'm definitely in the, if it's got active geology, it's a planet. Yeah. Yeah,
Well,
there's 30 some planets in the solar system. I'm totally down with that.
and
There's another presentation.
exactly, and these planetary bodies, the solar system, I think, is going to be highlighted in a lot of these planetarium shows that we're hoping to get off the ground in 2022. So, with that said, this is not a goodbye to Dave. It's a see you later, and then maybe in a few dozen souls or something like that, we'll just say kind of a nerd joke there. But And then just be on the lookout for the coming events, Special Astrophotography Special Interest Group. And next week we have that volunteer and info session. We're trying to revitalize that a little bit. So if you're just curious, you can always welcome and join us then. As we need more volunteers coming up in the spring, will come sooner than later. So thank you again, Dave. Thanks everybody.
All right, thank you
all right.
all. Thanks so much. Thanks
Thank
for
you.
having me, Aaron.